Hello and welcome everyone. So I'll be trying to explain this problem called Dora and search. So basically in this problem you're going to be given um, a permutation of length n and you're going to have to find out two values L and R, which are going to be the two indexes of the permutation itself, and uh, which should satisfy a condition, and that condition is that L and R index should be the two endpoints of a subsegment, and that subsegment needs to fulfill a condition, which is the two of the endpoints of that subsegment. Let's say uh, this is a particular subsegment, and this is the L and R. I can only output this L and R. My condition is that these two endpoints, the first one and the end one, these two endpoints should not contain the maximum and the minimum of the whole subsegment. That is the constraint here. And so how are we going to be able to pull this off? Now let's take a look at the one of the examples here. We would understand more. Um, let's take this example, 2, 1, 4, 3, 2, 1, 4, 3. As you can see, the answer of this array will be 1 and 4. Now why is that? As you can see, both of the endpoints here, I can take a subsegment of taking L as 1 and R as 4, a 4-length subsegment, which is fulfilling the constraint, which is the two endpoints are not having the maximum and the minimum of that whole subsegment. As you can see, 2 and 3 are not neither maximum or nor the minimum out of the whole subsegment. And so uh, there might also be a condition where you might not find a valid LNR. Let's say this could be an example: 2, 3, 6, 5, 4, 1, 2, 3, 2, 3, 6, 5, 4, and 1. As you can see, no matter which subsegment you take, there will always be a condition where two of the endpoints will have either maximum or the minimum. Let's take this example. Let's say you want this to become your answer, but that's not going to be your answer because, as you can see, the minimum belongs to the first index and the maximum uh, minimum belongs to one of the index. It doesn't matter which endpoints it arrives, just any maximum or minimum of the whole subsegment. If they arrive at any of the endpoints, uh, permis you are not gonna get the permission to make that as your answer. And so, first of all, we need to think about this solution as first of all, we need to as you can see, we're given a permutation, so maximum and minimum number, evaluating the maximum and minimum numbers possibility uh, is much more, and we can get easily the maximum and the minimum as there won't be any duplicate values. Secondly, you will notice that our probability of getting an answer, uh, we will get a maximum probability of getting an answer if we had maximum length of subsegment, because as the subsegment length shrinks down, if it's much more smaller, then the maximum and the minimum value of that particular subsegment there, the probability of those two values uh, being situated in both of the endpoints really increases, and we do not want that. So our best bet would be to go for the maximum subarray or the maximum subsegment. Now, what better way to do that than just take the whole array? Start with the whole array first, which can be considered as the maximum subsegment. And we also know the maximum and the minimum value of that subsegment, right? So we're going to go with that. And as it's a permutation, we will also get to quickly know what is the second maximum, what is the second minimum, and so on and so forth. So we will always start with the maximum subarray. Now let's go and dive into the solution. So for the solution part, the best example that I could give you is this one, 132, 132, 4, 6, 5, 7. Okay, 1, 3, 2, 4, 6, 5, and 7. Now, we will start with, as I've already told you, we only care about the two endpoints, nothing else. So we have two pointers here. The first pointer I goes to the first index and j goes to the final index. What we're going to do is just check the condition independently for each and every end, as we've got two ends of the subarray. So for this end, I will check my conditions independently. Also, I mean, both of these ends are going to get checked out independently. Okay, so, and what are we going to check? We're going to just check whether these are the maximum and the minimum or not. Currently, we've got the maximum what? We've got the maximum as 7, which is the maximum value of the whole array. What is the minimum? Minimum would be the minimum of the whole array initially. How are we going to find out the next maximum and the next minimum? Easily. We could easily do that because we are traversing from maximum subarray to the minimum. And we have a permutational array. So we know that if we want to find out the second maximum, it will be nothing but the previous maximum minus 1, and the next minimum would be the previous minimum plus 1. So easy peasy. So we're going to check whether both of these endpoints, whether they contain the maximum or the minimum or not. If both of these endpoints are not containing any maximum or any minimum of the whole subarray, and that's going to be my answer. That's going to be my LNR. If they do not contain, just like that here, as you can see, 1 is the minimum. That, as you can see, contradicts the constraint. Contradicts the constraint to get the answer. So we're gonna update our I to move forward. So we are not considering this index. We're moving here. At the same time, we're also gonna update the minimum value to the next minimum, which is plus plus, meaning the next minimum will be the previous minimum plus 1. So our current minimum changed to 2. Similar case goes to the other endpoints. We've got 7, which is the maximum. We do not need that. We're going to decrease that to find out the next maximum, which is 6. And we're also going to update our j, which is j minus minus. And we come to this point. Now, as I've already told you, I only care about the two endpoints. Now, if you just take care of the two endpoints, as you can see, 3 and 5, they do not contain, they are not neither maximum nor the minimum. So there you go. We've officially found out our answer, and it's going to be 2, 2, 3, 4, 5, 6, 2 to 6. And as you can see, the answer is also 2, 6. So independently, we're going to check both of the endpoints. If it's a maximum or the minimum, we're going to update our maximum or minimum. Also, we're going to update the index until we get a point where we get our answer, where none of the endpoints are maximum or minimum, and we get our answer. And that's going to be our answer. If we do not get a condition like that, of course, the answer would be minus 1. And so let's take a look at the code section here. As you can see, this is like taking the array. This is the while loop, traversing a 2-pointer. The first pointer is going to be the first index. The last index containing the last pointer, we're gonna move out with the while loop. And independently, as you can see, independently for each and every end, we're gonna deal with independently updating maximum and minimum if they occur, and we get our answer like that. And that's how we're going to solve this problem. Till next time.